Okay, and hello. I've returned to this project after a long time. A lot of this stuff, well, all of this stuff that's going to be covered in films PsoDRM7a,
Except that now that I've filmed
PsoDRM7a and put that together, I did so much during that filming that I've added even more information to what already exists just to get to where you are with your new ideas at the kitchen. So there could easily be DRM7C and D as well, but I will do what I can. These all stuff that I did back at the end of September and the beginning of October. And so I went through and re-reviewed this and actually went down and added stuff in starting at 710B or so. But I'm going to cover what I had done at that time. This was way back in September. This is where we had been, like this, with the two egress skylights here, and this kind of wider dormer than these ones here, and the full height walls here. So that's the first thing I did, is got rid of those full height walls. Now those are pretty low.
Something like
those are only
this.
like 33 or 4. This railing has to be 36, so it would start from these being at 36 or greater. I believe you said 4 feet, so they're shown low, 33 or so. And I kind of just wanted to see, because I know, and then I had worked some with dealing with these joists that are going across here, and we'll return to that. But there's not really, I had arrived at something like this behind that chimney for that area. As I said, I'll return to that. And then I took a quick look. I wanted to really quick cover this sort of thing. This is that existing dormer in place, and this was the proposed wider dormer here, and the two other existing ones here. And notice I even had to alter the chimney on that side just to make this work at all. So that was just a quick exercise and nothing. This, presumably, that dormer goes away and we use those skylights. And you can see it here where I've extended it to the back side of that chimney. You can also see it's not centered on that chimney as well. And the results are really about what you would expect. And while I haven't added the skylights back in, I did make a few other adjustments. These roof pitches are actually apparently 12-12, so those were adjusted up, and the chimney was put back the way it was. And this last dormer was brought in alignment with this one here, and made the same size as that, because I don't think it does very well as this oddball. So that's what I've done with that outside. And then return to the base, or coming to the basement. This is where I came back today and checked all these members down in the basement, including this problematic area here, for these next 20 or 30 slides. So these are the various members as I've named them under here. This one's fine. This passes, as does J0C. And these short ones, of course, pass as well. But we will return to this particular beam here, 0B. But the main joists pass as long as they're not Southern Pine number 2. I've assumed that they're Southern Pine or SPF, the main joists. Those pass. But these ones here, I have this double joist under that partition that separates the dining or the living room from everything else over here. And those are plaster walls. these are plaster walls, so putting in the weight of the plaster puts a pretty heavy load down through here. And drywall, if it was only drywall on each side of that wall, then it's only 45 pounds a lineal foot. But with plaster, it's 185 when it's on both sides of the wall. And that applies, you know, for all of these, this wall here as well. That's a plastered wall that's coming down on that problematic 0B. So we can say 45, but it doesn't matter because what we have is plaster at 185 pounds per lineal foot. When I put those in there, this fails pretty miserably. And even when I take out the floor loading, the normal floor loading, and just leave in the load of that plaster walls, it still fails. And worse, not even reflecting the loads from the joists over that living room area. So that's a real problem as far as I'm concerned, as far as I can see, unless there's something already been put in down there under that wall. And even if we did remove all that plaster and replace it with drywall to bring that 185 down to 45, we still have to account for these joists over the living room J1C. So particularly after we texted about the plaster, I came in and redesigned this particular member as a beam 0C and put in these loads. It's a little bit less than the first 5'9" because of the spiral stairway opening, and then it's the full length of those up to 15 foot, and the point load from that beam 1A between the dining room and the kitchen. All those loads on it, and I think that's about it. And selected those members including commodity lumber, but none of the commodity lumber passed, and we were with 2 11¼ LVLs. It looked like to do that. With this kind of loading here, which is like a 25-inch footing. I put this in as a 26 by 26-inch footing, and then the 4x4, and then these 2 LVLs. I don't know how easy those are going to be to get in there, what is situated under there right now. But that's what I did for that. And then, before I did any of this, however many, the day before that, I worked on this beam 0B. And some of this will have a little less meaning now, because I do think it would be well served to just strip off that plaster from this wall, from the top of the staircase, really all the way up to the ceiling at the second floor, just to reduce all of that load. But this was done with the assumption that that would stay at the plastered surfaces, 185 a square foot on the first floor, and a little less than that on the second floor. But when I first did that, that failed with what is there, which is just these 2 2x10s. This is all nailed connections, as near as I could tell from my photos. Some of this is covered up so I can't tell, but I assume this is a double beam like this one is, and that these are just nailed connections here, which that is definitely not going to work even without analyzing it. But these fail all across all the categories. And that was with this loading, and now when I switch that, put 45 pounds, 27, as if we did strip those walls. I still get the 2 2x10s failing across that for beam 0B. And so then I considered, well, if we split that with a prop between them, will that work? And I actually made the center a 4x6 to get more bearing on there, because there's apparently a lot of load, and that works, splitting that into 2 spans like this. And that's the loads on these footings. So you could do it that way and hold that up. But one of the things, the next thing that occurred to me, if this were the solution, one way or another we have to lift up, let's presume we take off all that plaster. That'll certainly make it, and we have to, because that's what I calculated for right now. That'll make that lighter and easier to move. nonetheless, it's still going to be hard to move. And unless there's a whole series of jack posts, I believe this was the other alternative to splitting it into two spans, is just cut that out and put in a 6-inch deep footing the whole way, and then build an actual wall underneath that whole thing. But regardless, first of all, that has to come up where it needs to be, or at least as close as we can get it to where it needs to be. And we saw that those two failed, and so I wanted to see what would it take for a single span to go across here. So in terms of lifting all of that up at once, my feeling was it probably wouldn't be a bad idea to just try to get a piece of steel, hopefully it's not too big, and then just have a couple footings on each side and slowly jack that up, and that would be the solution at the end with that steel plate. Maybe a wood plate is on top of the steel and then pushing up against all of those joists. So I went back to that 0B, double check the loads, the basement joists, the joists that are holding up under the kitchen floor, the ones that are over the kitchen ceiling, and that first and second floor wall, as well as the stairs load, depending upon how that's framed. And selected just for the W8 for now, and W8 by 10 passes, with that loading at the end. So this is what I ended up with doing there, is putting those 20-inch footings in, 20 by 20 footings in, letting that stuff cure, so that should be done as soon as possible, letting that concrete cure, and then using these adjustable columns and slowly lifting that whole structure. And then once it's up, we won't even have to put hangers on these things because that steel beam will be underneath them, and that steel beam will extend past these currently doubled joists here, and we'll be hoping to get this, just level up this whole thing up here on the first floor, and some of that extending to the second floor as well. Then we arrived back finally, because all of these were in recent days. October 1st. We arrived back finally to, and this is when I first started analyzing these members up here. How were we going to take care of those once we take out that wall? And that was those 2x8s, and they passed. So this was just J1A passes and J1B. But J1A, once we take, which is this one here, goes out over, and presumably those are, maybe they're single member. I guess they're two members, two 12-footers. They're lapped over that wall, and once that wall goes away, this is how I did it with a girder truss across here, and these existing ones interrupted and suspended on that girder truss with that existing roof framing over, the existing 2x8 or 2x6 roof framing over it. You could put trusses over it, but I did it more or less like this. I thought, well, maybe you could put this girder truss, because you don't have room. You could try to use some sort of a flush beam, but there's not room to do that. So, and this is what I did in this situation here, how to go across here and leave these existing joists in place with the new walls out here, leaving that existing roof framing as it is. So J1B over the master bedroom, those also pass. That's these ones here. Now when we get to this living room though, and J1C, which is a 16-foot out span, and put 40 pounds per square foot on that, assuming that that is what they will want up there on that second floor. And select 1 or 2 plies, 12 or 16 inches on center. It takes 2 of these. Notice that there's none of the single ply solutions that apply at 40 pounds per square foot. So currently this is what I have shown, so that we can accommodate 40 pounds per square foot on that second floor. In case you want to classify that as any number of rooms for now or in the future, and to handle the load that you might impose on But if we do put in 30 pounds per square foot, act like that's just a bedroom or associated space like that, if they'll allow that, then a single member will pass, but only if it's at 12 inches on center. And so that has to be field verified, whether those are 12 inches on center, even to hold the 30 pounds per square foot. For now, what I'm showing is that that's what I'm going to be showing for now on the drawing plans, unless directed otherwise. But at that time, back in October, the next thing I worked on was flush beam A, and we had a choice of making that a flush beam where this ceiling stays flat all the way through here. But that takes 4 of these LVLs. It can be done. It takes 4 of these LVLs, and 4 of those passed, but that was when the loading was 30 pounds per square foot on that loft up there. And if we increase that to 40 pounds per square foot, 4 of these won't do it, so we can't have a flush beam. So what we ended up with down there was, these are actually 2 9.5 inch LVLs here now. And we can't use the flush beam anyway, so this was kind of immaterial. Unless we rate that as 30 pounds per square foot up there, we can't use the flush beam, so we have that situation there. So if that flush beam is important, then we have to find a way to limit that to 30 pounds per square foot up in that loft. But there it is at 40 pounds per square foot, and 9.5 inch LVLs, 2 of them. So the next thing to check, other than the headers over these doors here, and we're not completely finished with this wall yet, was this area here. But before I did that, I went up and made the changes at this second floor that I wanted to make, which was making that dormer there the same as this one here. This is the overlay, and so we end up with several different members through here with different loading on them. And I went through and tested all of those members. Got that all sorted. And each of those we're able to use 2x8. So the big beam then at the end, single span, that's almost going to have to be an LVL. It will have to be an LVL, single span, and the least expensive option is 2 18-inch LVLs. So this is what we have here. Now I have these. This is all. So what we have to run is Southern Yellow Pine number 1 or 2 at 16 inches on center for all of these joists here, and it'll just be called J1F. And for this beam here, it's 2 18-inch LVLs. From here, well, I would just bring it over to this corner and to that column there. And this is how it works out. Remember, this is dictated by what you already have on your house, that fascia on your house. And this is the 18-inch LVLs, and those come right up underneath these 2x8 floor joists underneath the new space up there. And those are all 40 pounds per square foot loading, both on all of these joists and ultimately on that 18-inch LVL, the double 18-inch LVL. The next quick thing, we talked about this fireplace situation here. As I said, so much of this is very old. I want to try to get through it so I can get to the next part, because this is rather exhaustive. I know we had talked about an 11-inch hearth, and we wanted to bring that up to at least a 17-inch hearth. And when I did that, higher than that, I didn't move this up here. So that TV is going to have to be, this dimension here is going to have to be closer to 41. This is going to be closer to 40. So I'll update that right now and show you another updated piece of this with this in order here, because you can see when I moved that hearth up, the opening here did not move up with it. And so we need that space, so that's going to dictate the size of that television, the location of this. So the update of this diagram here is this. So the TV goes down to a 65-inch max diagonal with this sort of an arrangement here. That's the updated facade of that. And I'm still showing those 2x8s at 12 inches on center, but we already know probably we'd like to double these whether they're at 16 or 12 inches on center, double those and have 40 pounds per square foot loading up on that second floor. And that's arrived me at this spiral staircase. And first of all, the framing on that, knowing that these are going to change to doubles, but this would be the framing on this, and actually those 2x8s weren't working. So it's going to take a couple 8-inch LVLs here, and the rest of this as shown, to frame that up at about 5 foot by 5 foot. But I did some more research on these stairs to see exactly, to make sure I didn't miss anything, and that generally it's connected to the edge of the floor with a platform, and that platform is part of the stairwell, part of the stair assembly. And this is code compliant here. Okay, and our rise is, I believe, 108.25. Maybe it's 109. And to be, presumably, I don't know how they can do that in 11 and be code, but in any event, if it's code compliant, it's a rotation of 330, and if you change things around, you get a lower step riser here, disregarding code, and a bigger rotation, and all of this plays into where the stair starts. And they were showing these framing dimensions here, and I believe on this thing I framed for model 52S, and actually I'm not sure what I based my opening on. It looks like my finished opening is 62 by 62 inches, 5'2" by 5'2". But coming back to this graphic here, the standard degree is 27. And if we go back to here and ignore this, and I don't know if it needs to be code compliant at this point, but 27 degrees, 14 risers to the top floor with a total rotation of 351 degrees. So it doesn't quite turn all the way around, and that's what they're showing here. This is coming around to 350, whatever that was, 351 degrees is this rotation with this number of stairs. So it was going to be this clockwise or counterclockwise in terms of the layout on that staircase going up. But before we look at the rotation of this stairs and its location, we're going to take a quick outtake, because it occurred to me, even though we couldn't use 4 8-inch LVLs, perhaps a piece of steel similar to what is used downstairs could be used up there as a flush beam and create that condition. And it does work. And I know that we have some changes up here that we're going to make. But I kind of prefer this. Although it's not a big difference, that's just, I kind of prefer this with the flush beam, the flush steel beam. But in any event, it does pass. But leaving that aside for a minute, since I wanted to model that in there, I want to take a look at this downstairs real quick again, do some final adjustment there. And this is where I had it, where the center line of that steel beam was underneath the center line of that beam above. But that only puts about a ½ inch of this existing joist, and some of those are, I think, gapped over ½ inch already. So, plus that has a railing that goes up underneath there. But nevertheless, I think we can only really move that over to where this 2x6 plate on top of it is even with the edge of this. And that puts, you know, the steel beam is a full inch on to those existing joists, and the plate itself, so you have about 2½ inches here to take that slowly up. And when I look at that, this weight's not going to be on here when you push that up, but I was thinking I would probably cut the nails here before I even started putting it up, get this all assembled and cut the nails there, or cut all that resistance, or some of it. There is a lot of weight coming down on that after the fact, and this is a W8 by 10, and that's right here. And you know, all of these are kind of similar size, so maybe it makes sense to upsize that a little bit, because you're going to be pushing against that resistance in the first place to get that pushed up. And so this is the two options you have for this beam 1A. It's going to be 1A or 1A2. 1A2 is a flush steel beam, and 1A it takes two 9.5 inch LVLs. So you either have these two 9.5 inch LVLs and that's blocked down around it like that, finished, or you have this steel beam done very similar to what it's done in the basement, like that. And looking this way, these are shown as this 2x8s at assumed 16 inches on center, and if we want the 40 pounds per square foot, we're going to at least double 18 or 19 of those through there. And this finally brings us back to a regularly scheduled program with regard to this circular stairs. In these diagrams, the arrow is up from the bottom of the stairs. And so this first one is introducing the stairs down here at the bottom, like that. And these are the counterclockwise orientations. So I rotated that 90. So this is where you come up right here at the edge of this. You come up that 351 degrees here, and there is presumably a platform over here that is a part of that staircase. Then I came back to look at the clockwise ones. If you were starting here at number 1 and going up around, and then this is the platform here, and needless to say, I tried a variety of different arrangements looking at this, and I can't even tell at this point what I'm looking at, because this was back on October 2nd. But I do know that I finally arrived. I think you mentioned that you actually have recently had experience with some spiral stairs. So once you specify that, we can figure out all of the rest. But I know I came through here far enough to figure out that I'm pretty sure we're going to need a 12 tread plus 1, the landing, giving us 14 up to there. But we can figure that out at the end. I've made that opening finish out about 60 inches, 61 inches, and 150 centimeters for this 140 centimeter model is 59 inches. And our finish, with the way I have it framed now, is going to be 61. So it would accommodate any of these dull 140 centimeter ones. And then we can figure out exactly its rotation and how it interfaces. All of these, notice, have this like central point interface. So we would have to see how that works with this common area up here. It looks like it could attach right here, depending on how it winds down to the bottom. Right, and that's going to be the end of this video, covering the framing members, and to whatever extent was possible, because this went in so many directions. Here is an index that will hopefully